Hello and welcome to the YouTube channel D Creations Resources. We are learning mathematics, especially real analysis. Today we are going to talk about a topic called sets of numbers. Now we know that a set is basically a collection of objects governed by a certain rule. So here when you say there is a set of numbers, there is going to be some rule which is applied to all these, or rather that is the commonality between these numbers. So the first set, of course, is the set of natural numbers. Now numbers are usually associated with counting. So all those numbers that can be used for counting come under set of natural numbers. So 1, 2, 3, 4 and so on and so forth. Now to the set of natural numbers, if you also add 0, it becomes set of whole numbers. So set of whole numbers W is 0, 1, 2, 3, 4, 5 and so on and so forth. So set of natural numbers is the subset of set of whole numbers. Then if you also include the negative counterparts of the whole numbers, it becomes the set of integers usually denoted by Z. So minus 3, minus 2, minus 1, 0, 1, 2, 3 and on both the extremes, that is all the numbers greater than 3 as well as the numbers smaller than minus 3 will be incorporated here. Now there is a set of rational numbers denoted by Q. So it's basically if there is a number which can be written as a fraction, that is in the form a upon b, where b is not equal to 0, then we can say it is a rational number. So under that there are decimals that repeat. For example, the number 1 upon 3, the decimal form for that number is 0.333. You can see that 3 is repeating. Similarly, decimals that terminate. If you consider a number 0.53, basically the fractional form will be 53 upon 100. You can see that the decimals are terminating here. So both of them are examples of rational numbers. Then there is a class of irrational numbers. So numbers that cannot be written as a ratio of two integers. So non-terminating decimals, basically that decimals that do not repeat, they are irrational. Now to give you an example, pi 3.1415, the value just goes on. Or even the value of root 2, 1.41421 and so on and so forth. Both pi and root 2 are example of irrational numbers. Now set of real numbers R is basically set of all rational numbers as well as set of irrational numbers taken together. So all the numbers defined so far here in this episode are real numbers. So you must have understood that natural numbers are a subset of whole numbers which are a subset of integers which are a subset of rational numbers. And rational numbers are a subset of real numbers. Similarly, irrational numbers are also a subset of real numbers. So there is this kind of an hierarchy that goes on. And this is about real numbers. In the next episode, we'll be talking about the number line, basically the geometrical interpretation of real numbers. Thank you.